Hello everyone and welcome to the tutorial on Hess's law. Today we will explore one of the foundational principles in thermochemistry that helps us calculate enthalpy change for chemical reactions. My name is Adi Dahake and I'll guide you through this exciting topic. Hess's law tells us that the total enthalpy change for a chemical reaction is independent of the pathway it takes. This means we can break the reactions into smaller steps, calculate their enthalpy changes, and use them to find the enthalpy change for the overall reaction. Let's dive into an example to see how this works. Let's start off with a simple example, the combustion of hydrogen to form water. We need to find the enthalpy change, delta X, for the reaction hydrogen gas reacting with half oxygen gas to produce water. The first step is to adjust the given reactions to match the target equation. We are provided with the following data. The reaction hydrogen gas plus oxygen gas produces 2 water, has an enthalpy change of negative 483.6 kilojoules. However, our target reaction only involves one water molecule. Since only one water molecule is provided, we divide the given reaction by 2 to match the stoichiometry of the target reaction. Remember, when we divide the reaction, we also divide the enthalpy change by the same factor. This gives us delta H equals negative 241.8 kilojoules. And there you have it. The enthalpy change for hydrogen gas reacting with half oxygen gas produces H2O is negative 241.8 kilojoules. Now let's move on to a slightly more complex example, the formation of methane, CH4, from carbon and hydrogen. The target reaction is carbon plus 2 hydrogen gas produces methane. We are provided with 3 equations. The key to solving Hess's law problems is identifying how to manipulate these reactions to match the target equation. Sometimes we'll need to reverse reactions or multiply them to adjust coefficients. Here, we need to reverse the third reaction because methane is a product in the target reaction. Reversing the reaction also means reversing the sign of delta H. Next, we'll add the reactions and cancel out the intermediate compounds to obtain the overall reaction. After combining these reactions, we'll calculate delta H by summing up the adjusted enthalpy changes. For this reaction, delta H is negative 86.8 kilojoules. Now let's tackle a more challenging problem, the formation of propane, C3H3, from the carbon and hydrogen. The target reaction is 3 carbon plus 4 hydrogen gas produces propane. In this problem, one of the given reactions is an extra and isn't needed. Another reaction needs to be reversed and the third reaction needs to be multiplied. Let's carefully adjust each equation. First, we'll multiply the reaction carbon plus oxygen gas produces carbon dioxide. This will be multiplied by 3 to match the target equation. Next, we will multiply hydrogen gas plus half oxygen gas to produce water. This will be multiplied by 4. Finally, we will reverse the combustion reaction for propane to place C3H3 as the product. After aligning the equations, we sum up the adjusted delta H values to get the enthalpy change for the target reaction. The result is delta H equals negative 104.9 kilojoules. To understand why Hess's law works, let's look at a diagram. Each point represents a different state of the system and the arrows show the enthalpy changes. The direct path from A to D has the enthalpy change as the indirect path through B and C. This is because enthalpy is a state function. It depends only on the initial and final states, not the path taken. Hess's law is a powerful tool for calculating enthalpy changes, especially for reactions that are difficult to measure. To summarize, here are the key points about Hess's law. 1. Hess's law allows us to calculate delta H by combining known reactions. To do this, We can identify and align reactions to match the target equation. If necessary, reversing reactions and adjusting delta H accordingly will also help. Multiplying or dividing reactions to match the coefficients is another step that can be taken. And calculating the delta H value to find the total enthalpy change can be easily done if the previous steps are properly followed. By solving these steps, you can solve even the most complex Hess's law problems. Thank you for watching this tutorial on Hess's law. I hope this has been helpful in understanding this important concept. Don't forget to practice more problems to solidify your knowledge.